Okay, so let's now talk about reflections as transformations of functions. We can have two kinds of reflections. We can have a reflection across the x-axis. A reflection across the x-axis would look like this. If this is the x-axis, if we have something on the upper side of the x-axis, like a V shape, it would be reflected. This would be a mirror. It would be reflected across the x-axis, and it would look like a mirror image over the x-axis. Okay, that is a reflection across the x-axis. You can also have a reflection that crosses over the x-axis. Let's say that you had a V shape that did this. If it reflected over the x-axis, it would look something like this. Okay, it would basically, it's almost like you're taking the x-axis and you're spinning it 180 degrees so that what's above is below and what's below is above. That's a reflection across the x-axis. Same thing, we can have a reflection across the y-axis. A reflection across the y-axis would look something like this. If we had let's say a V shape here and we reflect it across the y-axis, it's like spinning it 180 degrees this way. What's on the right winds up on the left, and what's on the left winds up on the right, and so it looks something like this. That would be the reflection across the y-axis. Or if you just had a V shape here, a reflection across the y-axis would look, that's a little large, but you get I hope you get the idea. It would look something like this. Okay, we're reflecting over the y-axis, okay? And so the rule goes like this. So in order to reflect across the x-axis, so a lot of times what we do is we take an original function f of x, and then we call another function g of x the transformation of f of x. So we change f of x and call it g of x. So we'll say g of x is a reflection of f of x across the x-axis, that means vertically, right? If g of x is equal to the negative of f of x, straight up. All you have to do is take whatever f of x and do the opposite of it. So if the output at 5, so if f of 5 is equal to 7, then g of 5 is equal to negative 7. Okay? If f of 3 is equal to negative 4, then g of 3 is equal to positive 4. So that's really just what a reflection across the x-axis does, is it just does the opposite, the negative of the function. Here's an example. If f of x is x squared plus 5, then g of x is the reflection. That's going to be negative f of x. So we could rewrite that as the negative of the function x squared plus 5. Okay, the opposite, the negative of the whole thing, including the plus 5. We could then distribute the negative and get negative x squared minus 5. And you'll see that the graph of x squared plus 5 looks something like this. And so the graph of negative x squared minus 5 looks something like this. It's a reflection across the x-axis. Okay, now let's look at maybe a couple things in Desmos. Okay, so this is a fourth power graph. That doesn't really matter, but you can see right here. You can ignore all this stuff. Well, we'll see to it later. So what we have here is y is equal to x minus 2 times x minus 1 times x plus 2 times x plus 1, and this results in a graph that actually winds up already being symmetric across the y-axis. But we're going to reflect it across the x-axis here, okay? And when we reflect it across the x-axis, this high point is going to become a low point, and these two low points are going to become high points. And these curves that are sort of pointing upward are actually going to be pointing downward, because everything positive is going to become negative, everything negative is going to become positive, and everything positive here and here is going to become negative. And all we have to do is just put a negative, watch this, all we have to do is just put a negative in front of the whole thing. Just put a negative in front of the function, and look at that, it just flips right over, okay? That is a reflection across the x-axis. Okay, now very similarly, we have the reflection across the y-axis. That's a y-axis, it's like we're spinning the y-axis 180 degrees. And a reflection across the y-axis, we can say that g of x is a reflection of f of x, but across the y-axis, if g of x is equal to f of negative x, okay? And so this is our first look at something really interesting. We can see that in both cases we're putting a negative on, but where we put the negative determines whether it's a vertical flip over the x-axis or a horizontal flip over the y-axis. And what we're going to learn is this, is that when we put things that affect the whole function on the function, it causes a vertical change with respect to the x-axis. And when we put things only on the x, not on the whole thing, but only on the x, it causes a horizontal change with respect to the y-axis. So here's an example. Let's say that f of x is equal to x cubed plus 7. And so then g of x is going to be equal to f of the negative of x. And so g of x is going to be, so we're going to, in for x, we're going to replace x with parentheses, and we're going to put in the negative of x. And so the reflection over the y-axis of f of x would be g of x, which is the negative of x cubed and then plus 7. And this is an important distinction too. Look over here how the negative affected both the x squared and the 5. So it became negative x squared and negative 5. But on the reflection across the y-axis, it's only changing the x. It's not affecting the 7 at all. The 7 is not becoming negative. Only the x is becoming negative. Let's see what this looks like maybe in Desmos. Okay, so here we have a graph. This is a square root function. You can see that this is f of x. We call this f of x. Y is equal to the square root of x plus 2. And if you're unsure, I can go ahead and I can show you that I can just key in f of x instead of y, and it gives me the exact same thing. So f of x is equal to the square root of x plus 2. And let's just try to type in, what if I just said g of x is equal to f of the negative of x? Oh, look at that. And so it actually went ahead and gave me a graph that is a reflection across the y-axis. But I can also accomplish this just by going up to the function itself and going into the x, going to where the x is, and just putting a negative on the x. And now the x has been negative, and you can see that it flipped around the y-axis. Another interesting way to look at this is if we looked at something that was, instead of the square root of x plus 2, how about the square root of x minus 2? So you can see that it starts here and it goes off to the right. If we reflect across the y-axis here, this point should be right here, and this point right here should be reflected over here. So it should start here and go through here. In fact, it should start at negative 2 and 0, and it should pass through the point, because it goes through the point 3, 1, so that means it should pass through the point negative 3, 1, and let's see if that happens when I change this x to a negative, and sure enough, it passes right through those 2 points. And so this is a reflection across the y-axis.